So let us try to understand what quantum mechanics says about scattering. Okay. So let me give you an example of scattering. Consider you have a hard sphere, and upon this hard sphere, consider there is a small ball approaching the sphere. Now, if this ball comes straight, hits the sphere, then obviously this ball will go at a particular angle. Okay. So this is called scattering. So it comes, hits the hard sphere, and goes to other direction. A hard sphere is represented by a potential where potential is infinite. When I said infinite, that whatever may be the energy of the ball, it can never penetrate the ball. This big sphere can never be penetrated. Okay, this is the meaning of potential is infinite. Now consider same thing. Consider a potential wall here, and consider there is a particle with energy E, and in case number 1, consider this particle has energy which is far greater than the potential V naught. Then what would classical mechanics says? Classical mechanics says that if you have a stream of particles that have the energy greater than the potential, then all the particle will go here. All the particle will be found here. That is, it will overcome the barrier and it will go forward in its own direction because the energy is greater than the potential. But quantum mechanics will tell you something interesting. Quantum mechanics says there are some particles, and these weird particles, even though they have the energy less than the potential, still instead of overcoming the potential, they will be reflected back. So there will be some particle who will get reflected after hitting the potential. This is quite amazing. Now because even if you have energy greater than the potential, so when you have energy greater than the potential, it's quite illogical that the ball, some of the ball can hit the potential and come back. It's quite illogical, but quantum mechanics says, hey, this is true. It seems illogical, but there are some particles which can have energy greater than the potential, but still they will reflect back and go towards the origin. Okay, they will reflect from the potential. In another case, consider a stream of balls coming towards the potential, and each of the ball have energy E, and say unfortunately this energy is very less than V. So if the energy is less than V naught, then logically classical mechanics will say, hey, everything will reflect back. Everything will reflect back because the energy is less than V. You cannot have any particle penetrate the barrier because your energy is less than the potential. But when you apply quantum mechanics, I mean, when you apply the quantum mechanics, when I say when you're applying the quantum mechanics, it means you are considering the wave nature of these particles. So when quantum mechanics is applied to the system, quantum mechanics says, hey, there will be some particles whose energy may be less than V naught, but still they will penetrate the V naught and they will go forward. This looks again quite disturbing. How can a particle having energy less than the potential penetrate and go? It's not possible. But quantum mechanically, the wave nature of the particles make it possible. Okay, so there is one more interesting effect called as the tunneling effect. So consider this is a region, and there is a potential here, and this is another region. So consider the potential here is V naught, and there are particle coming towards. So in this region number 1, the particle is free, no potential is there. In region number 2, the particle is free, there is no potential. Just in region number 3, that is in between, there is a small potential V naught. It is also found that there are chances quantum mechanically, when I explain this phenomenon, there are chances some of the particle will get reflect back and some of the particle will overcome the potential and go forward. Whatever may be the energy, whatever may be the relation of the, whether the energy is greater than V naught or the energy is less than V naught, you can see both these things happening. Okay, so quantum mechanics says the particles, I mean the quantum particles can pierce the classically restricted region. So this is an amazing thing about quantum mechanics. So for example, let me give an example. So our sun, what happens in our sun? You know that in sun, hydrogen two hydrogen atom, they come, they fuse, and they make helium. And in this process, they liberate a lot of heat, and that we get as the sunlight. Now, the logical thing is, how can fusion occur? You'll say, why? What is the problem? The problem is the hydrogen core has proton that is positively charged, and this is also hydrogen whose core has proton which is positively charged. Now question is, how can these two positive charge repel each other and mix with each other and make helium? The reason is quantum mechanics. Quantum mechanics allows these two hydrogen atoms at very high energy to overcome the Coulombic potential, tunnel through. Again, tunnel through is a word that I'm using because tunneling is a process that only occurs and allowed by the quantum mechanics. So they tunnel through the Coulomb's barrier and the fuse, making the helium. So without the tunneling effect, which is allowed by the quantum mechanics, the sun would not have given us light. The very fact that two hydrogen fuses to become helium against the Coulombic repulsion is allowed by the quantum mechanics. So this is a real life example of quantum mechanics. That is really something called as tunneling. Because you see, classically, if you say touch, make the two positive charges join each other, you would say, hey, there is Coulomb's repulsion between two protons. They will always repel each other. They will never come near each other. The Coulombic potential will not allow them to come near each other. But quantum mechanics says, hey, I can allow tunneling, and the quantum mechanics allows the tunneling, makes the two hydrogen atom fuse by tunneling, overcoming the Coulombic potential. So there are many amazing application of quantum mechanics in real life too. So quantum mechanics is not that something abstract, but it is something that we really find in our nature, and because of quantum mechanics we are alive. Okay, thank you for listening. Bye bye.